Hey guys, it's Simon and welcome back to the LibGDX Kotlin RPG tutorial series. So this part took now quite some time to record. I hope that I have now enough time to do it because currently my wife and my son are sleeping, so I hope that I will have enough time, but let's see. The problem is a little bit that the code is now a month, maybe even more old, and I haven't looked at it, so I might struggle a little bit explaining everything to you, but I will give my best as always, and I hope that everything is clear. So in this part, as someone requested in the YouTube comment sections, we are going to develop an inventory system using the drag and drop functionality of libGDX, and it will look something like this. So when we press the I key, we open our inventory where we have a couple of items currently available. The items itself are entities, so we are going to reuse our entity component system approach for that. The items don't have stats, so they won't give you life or move speed or damage or whatever, but I think you can figure out that on your own with everything that you have learned so far in this tutorial series, and you can build whatever you want to have. What we are going to do is that we have this inventory here. We can then drag and drop items around. The item will follow the mouse cursor when we drag and drop it. On the phone it would be with touching, so with the finger it will follow then the finger. We can swap the items in the slots, and we also have here on the right side a gear. So this is the items which are equipped by our character, and there, for example, we can give him some boots, and they can only be placed in the boots inventory slot. If we try to drop it in the weapon or helmet slot or armor slot, then they are colored in a red color so that we cannot drop them there. And if we put them in the boot slot, for example, then it works. Similar with the helmet and with all the other items that we are going to develop. Same with the weapon, and it's also possible to swap the weapons out. So with the swap an item in the inventory and do all of that stuff. This is what we are going to develop in this part. So if you're interested in that, stay tuned. Okay, but before we dig into the details of the inventory system, I want to mention two things because there are currently two problems in the code. The first one is in our camera system. So that one I did not test properly, it seems, because the resizing, of course, everything is working great and looks good. But there's a problem if the width of the window gets too small, then our game is crashing because our coerce function has the problem that the minimum and the maximum are sometimes swapped around, so an empty range as we can see it here, and then this does not work. So that's why we need to make a little bit of an adjustment here and check what is the minimum width of our camera and the maximum, and then pass it correctly into our function here. So here the width and the height is not sufficient, so what we need to do, we need to know what is the minimum width of our camera, and that is simply what we pass in here. So it's the view width or the maximum width minus the view width, and the same we need to do with the maximum. So the camera maximum width is the maximum of those two values, and the same with the height of the camera. So it's the minimum height and the maximum height, and there we pass in the value from our height. And then here in the function below, there we need to pass in the camera minimum width and the camera maximum width, so that we always have a correct range in here and that we don't crash anymore. So that's a small fix in here in the system. And now if I did everything correctly, then we can now correctly resize our window to whatever aspect ratio we have, and we should never crash. So the camera is still centered around our character, so that one is totally fine and working. But when we are going now into a super small window, then our game is not crashing and everything is still working with the camera system. So that's a small fix to the camera system. Then there was another small thing that was mentioned by someone on GitHub, which is actually a problem with our player movement speed. Because when we are moving diagonally, the word that I cannot pronounce correctly, then our character is actually moving faster than he should, and not going correctly the speed that he's going left and right, up and down. When he's going in this diagonal way, then he's moving faster. And the reason for that is that the the cosine and sine value that we pass in for the movement are both 1 when we are going in those directions. And that is not correct, because actually when we have an angle of, for example, 45 degrees, then the cosine value is, the sine value are not 1 and 1. They're actually, I think, 0.7 something and 0.7 something. And the user mentioned that this is a bug, but I would say that it's maybe intended, because I think in the old Super Nintendo games, role-playing games and so on, they, I think also when you move diagonal, then you were a little bit faster than just moving horizontal or vertical. But we can fix that, but I don't do it now here properly in this code. So I think you can check out the GitHub code there. I fixed it properly, and an easy way to solve that problem is that we simply need to normalize the vector that we pass in here. So what we could do here, let's just create a temp vector here, for example. And what we are then doing, so in here, those two values, before we set them, we set it to our temporary vector that we currently created, and then we call the normalize function on that specific vector. And what that is doing, it simply delivers then a vector with a length of 1, so that we don't have then the cosine and sine value of 1 and 1, and we would then move faster in our movement system. With this normalization, we then really get the values 0.7, 0.7 something, and we then don't move faster. And then we simply use here the x value and the y value for the movement, and then we have that fixed so that our diagonal movement is then also with the correct speed of the horizontal and vertical speed. So that was a small, yeah, you could call it bug, but I would not really call it a bug. It was more like a feature. We don't have this problem with our AI entities, because there we actually use the angle calculation, I think with the Arcus Tangens 2, something like that, that we get the correct angle between the player and the AI entity. So there the movement is already correct, but our player was able to move faster because we set both cosine and sine to 1, and this is not correct. And with the normalization of this vector, we then pass in the correct value so that our player is no longer moving faster in that specific directions. Okay, and with that we can then start and dig into the inventory system. Good, so let's start with a similar approach like we did it last time, which means that we are going to simply start with a test screen, so a user interface test screen, so that we can quickly build up our user interface for the inventory without the logic or the interaction yet with our real game model. We just going to develop the user interface first. So let's rename that previous UI screen that was more like the game UI screen. Let's call it like that. And let's also create now a new one, and that one we call inventory UI screen. And now we are going to create this screen, and we also for now are going to set this screen then afterwards and disable our game screen for now. So let's just copy and paste the game user interface screen. And then let's adjust it a little bit. So what we are going to need, we for sure need a stage, which is our user interface stage. We need most likely a world with a player entity, which contains then the items and so on. Then we're going to need a new model. So in this case, it's not the game model, it's an inventory model. This is a similar approach like we did last time. So it's this model view model approach. And we also need a new view, which is called an inventory view. Then our player entity needs the player component, and we also need to create a new component. Let's call that an inventory component. So this is the component that will then contain all the different items that our player is going to carry, and these items are then visualized in our user interface. Then in our show method, we also take over the same thing. So we have this listener in our stage, so that will be our model. And we also have a new view, which is no longer called the game view. That will be our inventory view. We are going to create all those classes in a moment. We also need then a new DSL, a scene to DSL for our inventory view to create that, and we want to have the debug mode. And for now, we are only interested in the R key to reload our user interface, and that's it. So then let's start. So let's create a new model as well. This is simply an empty model for the time being. So a new inventory model. That's it. And let's import that. And we also need, and also the constructor, of course. We need the world and the stage here. So just for now, let's quickly remember the world and also the game stage. But this is going to implement it later on, as mentioned. So this is then really, if we want to interact then with the real game, so with the real game model in the end. For the time being, we are only interested in developing the user interface, so we don't care a lot about that. Then we need a new view, which is our inventory view. And let's also import that. And we also need a new component, an inventory component. Which also for the time being, we just leave it empty. Good, then our inventory view, that one takes, like it did, like our previous view, it takes in the model, which is in this case the inventory model. And it again extends the table class, so the K table from LibKTX, and also the normal table where we pass in the skin, which also gets passed as an argument to the constructor of our inventory view. Okay, and finally the DSL, so that we have this nice inventory view syntax. There we are going to create a new scene to DSL. This is everything that we have learned already in the last video, but just as a little bit of a reminder, let's say, or as a practice, let's write it down together that you have another example. So there we take in the inventory model to create the view. We take in the skin, which is per default the scene to the skin, the default skin. And we're gonna have an initialization block of our inventory view, which is per default an empty function. Okay, so this is a capital S. Then we need to import the K widget. And what this function is doing, it returns an inventory view. Which is an actor. There we create our inventory view, pass in the model and the skin, and the init functionality to initialize the actor. Okay, and also imports the actor, and that's it for now. So that should be the DSL. Now coming back to our inventory screen, we can import that. Oh, and our inventory model, that one we need, it needs to be an event listener. And implement the handle method, which we don't care for now. Okay, so that's our test screen. So let's quickly test it. So when we start up now, we shouldn't see our game. We should hopefully see just a black screen. Oh, here we also need to import now our screen that we have created. And now we should see just a simple black screen. Okay, perfect. So that one is working. So next thing what we are going to do, we're going to focus on our inventory view. So let's close everything else, because this is now the important part where we are going to add now again our user interface stuff. So again, to save some time, I don't show you how I create a new user interface texture atlas and what kind of textures we are using there. For that, I think we have seen that a couple of times already in that tutorial series. Simply download the user interface atlas from the GitHub repository or use your own graphics, whatever you prefer. And yeah, as mentioned, I will skip that part here. So in our constructor of the inventory view, what we do, so First of all, we will split again. First of all, we're going to implement the user interface, and then later on we will have this data binding. I think we called it the last time, but that one we are going to implement later on. For now, we focus on the user interface. Our table is going to fill our parent, so it fills out the entire stage. And then we are going to have two tables. We will have the inventory table on the left side, which has our entire inventory and all the items. And then we have another table on the right side, which I called gear, so which is basically the equipment, so the things that our character is carrying at the moment. So let's create two tables, table 1, and here another table, table 2. And that one has a cell, which we can call inventory table cell. Okay, so the background of that table is from our skin, and there from our drawables that we have, we use the frame background that we already introduced last time. I still have this bug that for whatever reason it cannot automatically import the get function of our skin, so I need to manually import that all the time. Let me know if you have the same problem. Hopefully it gets fixed in another version of IntelliJ, but yeah, whatever. Then we are going to have a label in this table, so which is mentioning this that this is the inventory part of our inventory user interface. So here the text is inventory, and the style is a new style that we did not introduce yet. There we are going to create a new title style in our labels class, which is simply a little bit of a bigger font than in the end. And I think I added a grayish color if I remember correctly. And this time we are going to make it correct, because last time I think I forgot to sometimes pass in the skin itself to the different widgets, so that if we would actually use a different skin and not the default skin here, we pass that correctly to our widgets. So let's quickly go to our labels, and there let's add a new one, which is called title. And that one we are going to create below here. So let's just copy the frame section here, but here we are going to create the title font. And what we are going to use here, we are going to use a new font, which we will call then big. So it's not the default font, it's a little bit bigger than that, and it has a specific color. So there it has this color. Slate is the one that I used here. The background is still the frame background, and the padding, let's say, of this texture is also the same as we had before. So what we are missing now is here the big font, so let's also create that one. So here we have a big font. The font is still the white font that we had last time, but now it's a little bit bigger, so this one is 0.5 instead of 0.2.5. And that's it. So this is our title label skin. I'm going to show you that in a moment, how that looks. Let's quickly implement the rest of the inventory view here, of this inventory table part here. Okay, so our label, we want to adjust it a little bit, so it should be aligned in the center. And the cell itself, it should expand horizontally, so on the x-axis, it should fill the entire space that it has. It should have a padding of 8 on the top part. Then let's introduce a constant for that, so a title padding, because we're also going to need that for the second table as well. Then on the bottom we don't need a padding, and on the right side it's again a title padding. And that one, let's define it, yeah, for example here. So here we have a title padding which is 15. Okay, then we want to have that on the top of our table, and we want to have then a new row for the different inventory slots. Okay, and below that, there we're going to have another table, which is now let's call it the InventorySlot table. So these are now the different slots that we have in our inventory, and those one we implement in a moment. For now, we simply say that the cell that we have here, so this InventorySlot table cell, we want to expand it and we want to fill it. So that one should be as big as possible. And for the surrounding table itself, that one we also want to expand. We want to say a specific width of 150 pixel, a specific height of 120 pixel. We want to have it on the left side, and we want to have it centered. Okay, so how does that look at the moment? So let's open it up in the debug window so that we also see this nice little trick with the R button to refresh our user interface. Okay, so that already looks good. So this is our inventory table for the time being. So we have this title label here at the top with the bigger text and this grayish color. So this is this so-called slate color. I never heard it, but I simply use it from LibGDX. So this is the color that for me looked okay-ish, but I'm not a graphical designer. And what we are currently missing is here the different inventory slots below. And we are also missing the table on the right side for the gear. So let's quickly introduce the gear table for now. So this is the gear table cell, and this gear table cell, oh, not great, gear table cell, today I'm not typing very well, sorry for that. So gear table cell, this one we also going to expand. This one has a width of only 90 pixels. It has a height of 120 pixels, so that it's the same as the inventory on the left side. And that one is also left and centered. And it also has a background, of course. So the background here is from the skin again, and it's again the frame background that we had before. And we are also going to introduce a label here. So let's copy that stuff from above, and that one is called gear. It's again the title skin. It has the same alignment, and it has the same padding properties than above. Okay, so let's refresh the classes, and now let's press the R button to refresh our inventory, and we already see that a mistake happened. So here we, for example, did not set yet the cell properties of the label itself. So that's why it's here at the bottom. So let's quickly fix that as well. Oh, actually the cell is correct, but we forgot to add the table below. So let's do that. So that's why the label is not pushed to the top. Let's call that, I don't know, gear inner table cell. And that one we are going to expand and fill. And now let's refresh and reload. Perfect. So now we have those two tables here with our title, and yeah, everything looks good. So the next thing that we are going to introduce is that we want to have here the different inventory slots, and that is a little bit similar like the character widget that we created last time. So we will have the slot background texture, and on top of that we are going to add an item texture if there is an item in that specific slot. So again, we need this stack of images, let's say, but as you hopefully remember, we don't want to have the stack widget because that behaves very weirdly. We want to have this, how was it called, I think K group widget for the grouping of the different inventory slots. So for that, I quickly need to get the user interface atlas from the main project so that I have the graphic available, and then we are going to implement that specific inventory slot widget. Okay, so let's go up here. So this is here our inner table for the inventory slots, and how many slots do we want to have. So let's say we want to have 18 inventory slots in total. So this is the amount of items that we are going to show, and here we are going to create a new inventory slot where we pass in our skin, and we will get a slot cell back here, and that one has a bottom padding so that the cells are not clustered together, let's say. And also every 6 slots, so after one row of slots is available, we want to have a line break. So we want to have a new row. So with I modulo 6 is equal to 0, then we want to call the row function of our slot cell to make a new row, and otherwise we are going to make a padding to the right to also have a little bit of a spacing in between the different slots. So what we are missing is an inventory slot, and this is simply a new widget that we can create in our widget package. Let's call it InventorySlot. So let's start with the scene2D DSL again. So again, we have this function. And it's called InventorySlot. So what does an inventory slot contain? So it contains the item graphic, which is a drawable constant that we are going to define. And per default, the slot does not have an item, so it will be null. And other than that, again, we pass in the skin and this initialize function. And this function returns then an inventory slot, which is again this actor. And to the real class, we also pass in this slot item background, the skin, and we call the initialize function. So our slot takes the slot item background, and it also takes in the skin. And it is a widget group. Oh, it's just a widget group, not a K widget group. And a K group. This is how it was called. I forgot about that. Okay, what we are going to need for our slot, we need a background, which is an image. And there we simply take it from our skin. And there we are going to introduce a new drawable, which is called InventorySlot, which is basically the frame background graphic, but a little bit smaller so that it's a little bit round. Yeah, it's actually a rounded version of the frame background. Let's quickly create that. So we go to our drawables. There we are going to create a new inventory slot, and the key in the atlas is called inv_slot. Okay. Okay, then after the background, we are going to have an item graphic, which is again an image. And here we have it. So if our slot image that gets passed in is null, then also our item image is null, and otherwise we are going to add an slot item background. And sorry, that one I said that's the item graphic, but it's not the item graphic. It's actually from the gear inventory slot. If you remember from the introduction where I showed it to you, there we had some light grayish background of the gear type. So in the helmet slot, there was a gray transparent version of a helmet. In the boot slot, there was a gray transparent version of the boots. So this is the slot item background graphic. A normal inventory slot does not have that because there we don't need it. Every item can be part of a normal inventory slot. But for the gear slots, where we're also going to reuse this widget here, there we can set the specific background graphic to indicate what kind of item you can drop into the gear. That will make sense in a moment when I show it to you when we have that part finished. And yeah, finally we have then the real item image, which is a normal image again. At the beginning with no graphic. Okay, and in our constructor we are going to create this group. So first of all we are going to add the background graphic. If we have a slot item info, so if we have that available, then we are going to add it also to our group, but we are going to adjust it a little bit. So as mentioned, it's a little bit transparent. So we're going to set the alpha value. We are going to adjusting the position a little bit, so that's a little bit moved to the top and right by 3 pixels. And we are going to set the specific size so that it fits perfectly into the slot. And we are going to set the scaling that it should be contained in the size that we have specified here. So I think this is very similar to last time what we had with the character information. And finally, we are going to add the item image, and there we are also going to apply the same settings that we have here for the background image. So let's copy and paste that down. And yeah, as you might remember, this does not work properly if we don't override some functions. So we need to return a preferred width and also a preferred height. And this is simply the size of the background graphic. So we are going to use from our background drawable, we are going to use the minimum width, and for the height we are also going to use from our background the drawable, we return the minimum height. Okay, so far so good. I think that looks okay. So let's go back to our view. So there we can now import our inventory slot. And we need to pass in the skin like that, because the first argument, so this slot item background is the first argument and not the skin, which defaults to null. So thanks to Kotlin, we can simply pass in the skin like that and skip the other arguments. So that's it. So let's quickly start that now, and again in the debug mode, so that we can see the changes in a better way. And that is looking already great. So these are now these inventory slots. So here we have the background image. So this is this rounded version of the frame background at the top, a little bit adjusted. And inside we would have this optional background image of the gear that we will see in a moment. And of course also the item itself. So this is a slot. The slot contains of maximum 3 images. So that is looking great. Also that amount with the rows and the padding and everything is working well. So let's now add the gear slots which are currently missing. So here we want to have an inventory slot. And what we pass in here is from our drawables. We are going to create an inventory slot helmet, which is then this background graphic for the helm gear slot, and we pass in the skin, and we want to have here a bottom padding of 2 pixels. This one is going to span over 2 columns. We understand that in a moment, and we want to have a new row, and that one we are going to need 3 more times. So the next slot in the second row is then first of all the weapon, where we don't want to have a new row. So there we just want to have a padding to the bottom and a padding to the right of 2 pixels. And the next one is then the armor that we are going to wear. So there again we want to have then the next row, and in the last row we are going to have our boots gear slot. That one does not need a padding anymore because it's the last row, and that's it. Okay, so let's create those drawables. So we have the helmet, we have our armor, we have the weapon, and we have our boots. So for the helmet it's the helmet key, for the armor it's armor, for the weapon it's weapon, and for the boots it's boots. Okay. So let's restart it, and now we should hopefully see already our gear. And we do, and now you also see this background graphic that I mentioned before. So here we specified that we want to have this helmet graphic, and this has an alpha value of 0.33. And what else? I forgot it. I think it's just the alpha value if I remember correctly. And same for weapon, armor, and boots, so that the user has an indicator what kind of item type he can drop into what kind of gear slot. So that's this background graphic, this optional background graphic of an inventory slot. Okay, and I think actually from a user interface point of view, that's it so far. So we can then turn off the debugging so that we don't see so many lines anymore. And what is important, we need to remember, of course, some of our widgets here, because we need to interact with them and update them accordingly. So what we are going to need, we need to remember our inventory slots, which is a mutable list of inventory slot. And we also need our gear slots, which is also a mutable list of inventory slot. And here we are we are saying that from our inventory view, from the inventory slots, we are going to add the slot here. And below here we have, again, from our inventory view, the gear slots. And we are going to add our different gear slots there. Okay, so we also store those now, and now we could potentially interact with them, which is great. So let's test it if that is working properly. So we want to add now an item graphic to our inventory view. So for that, we are going to create a new function. Let's call that item. Let's make it public for now. And there we pass in an item model. So what is an item model? Let me explain that in a moment. What we are then simply doing from our inventory slots, we take the slot of the item model. So where is it located in our inventory? And there we set the item graphic to and pass in again the item model. So we set the item of the inventory slot. We are also going to implement that in a moment. So what is an item model? Again, I normally try to distinguish between the real data model of the game, which would be in that case the different item entities that we are going to have with the different components, and the user interface. So I could, of course, pass in the entity graphic, the slot index, and whatever I get from the different component data out of the entity. I could pass directly to the user interface, but in this case I don't really like that, so I created a separate model again, which is specific for the item and represents the most important part, or the important pieces that the user interface needs to properly work. So similar to the inventory model and game model, we are going to create an item model now. So let's create a new class, which is called item model. And the information that we need in our user interface is the following. Our item model has, first of all, an entity ID. So to which entity does it belong, so that we have a linkage between the user interface item model and the real game item entity. Then it has a so-called category, which is an item category that we are going to introduce, which is it a weapon, is it a helmet, is it a boots, and so on. So this is important for the gear section of our inventory, that we cannot drop, for example, boots into a weapon slot or a helmet into a boot slot, so things like that. Then we have the atlas key, so the graphic of the item. We have a slot index, where is it located in the inventory, and also the information if it is equipped, so if it is part of the gear table of our inventory, or if it is part of the normal inventory section of our inventory view. Okay, so for the item category, let's also create a new component that we're going to need later on, which is then the item component. So these entities which have an item component, they are then our item entities in our game. And therefore now, yeah, let's keep the item component for now empty. What we are interested in is the item category. And there, as mentioned, we have, so first of all, undefined. If it's not properly defined, we have a helmet, we have an armor, we have a weapon, we have boots, and that's it. You could also add here, for example, I don't know, consumable, gloves, whatever you want to add there as an item category. For us, these types are sufficient for now. So coming back to our item model, we can now import the item category, and coming back to our view, we can now import here the item model. So the next thing that is now missing is the item function of our inventory slot. So how does it work? First of all, so our inventory view, when we call the item function, we pass in an item model. A model has a specific slot index. We ignore for now that it could be equipped or not. That comes later on. We just want to see it in the inventory for now. And then from that specific slot, we call the item function and pass in the model. And this slot now needs to update properly. So it needs to change the item image graphic that we pass in here. So let's go to our InventorySlot. Let's create here a new function which we call item, where we pass in the ItemModel, which could be theoretically null if we want to clear the slot from a specific item. And of course, our slot should remember what kind of item it currently contains. So there will be an ItemModel which is of type ItemModel, and by default it's null. So by default the slot does not have any item in it. Okay, and in here, so we assign then whatever model we get passed, and if the model is null, then from our item image the drawable will be null, and otherwise the drawable will be from the skin, and there we're going to call the getDrawable function, and there we pass in the atlas key from our item model, and that should be it. Okay, so just that you see it, so in the user interface atlas, there we have the graphics inside. So there we have this weapon, helmet, armor, the different swords, the boots, and so on. So everything is in there. And now for testing, let's take, for example, the boots. So this is the atlas key that we are going to pass, and let's try to add that to our inventory. So we are going to add something in our inventory screen. And here, let's say, for example, when we press the number 1, then from our inventory view, we are going to call the item function, and let's create a new item model for now. Entity ID we don't care for the time being. Item category would be boots. Atlas key would be boots. Slot index would be 1, for example, and it's not equipped. And when we press the number 2, oh, we actually cannot clear it. Yep. So here we would need to pass in somehow the information of clearing the item. So yeah, that comes on later. That does not work at the moment. Then let's make a helmet, for example, so that we see at least the second item, and add that to slot index 3 as an example. So let's try that out if that is working. Okay, and that also get rid of the debug lines first, because they are now quite annoying. Now that we are finished with our user interface, we are happy the way it looks, so we don't need that anymore. Okay, so this is how it looks, and now I'm going to press the button 1, which is going to add the boots to our inventory, and when I press 2, then we are going to see the helmet in our inventory. So from a user interface point of view, everything looks good so far. So we cannot drag and drop the items around yet, so that is the next part that we are going to implement. And currently we cannot add something to the gear stuff, and we cannot clear items, but I think as a starting point that is more than good enough for now. Perfect. So let's now continue with the drag and drop part functionality in our user interface. So after we have set up all the user interface stuff, and we have also stored our gear slots and also the inventory slots, we have all the information available that we need. So the next thing that we are going to do is now to, let's call that set up drag and drop. So this is a separate function because there is quite some code in it that we are going to go through now and that I need to explain. So first of all, for a drag and drop, we can create a new instance of a so-called drag and drop class. So this is coming from Scene2D, and the way it works is that you define so-called drag sources and drag targets, and you can then drag and drop something from a source to a specific target. In our case, all our inventory slots are sources and targets because we can freely drag and drop items around between the different slots. So we can try to drag an item from slot 1 to slot 3. We can also try to drag it from slot 1 to the gear slot and so on. Of course, there will be some restrictions in the gear slot sections that we cannot drop everything there, but potentially we can drag and drop between the different slots the way whatever we want to do there. So every inventory slot will be a so-called drag source and also a drag target. Then there is some settings that we can define in the drag and drop. One of them is called the set drag actor position, which is yeah, I think it's a little bit of a misleading name. What it basically does is adjust the image that that we are going to show when we are dragging something. So that we have the item sticked to our mouse cursor, and we want to have that centered. So that's why we need to offset it a little bit. So there's a set drag and drop position. For now, I won't set it, so that you then see the difference between this function call and so with this function call and without the function call, but just that you have heard of that. Then another important function is the drag time, exactly. There you could imagine, so when you do very quick, maybe you by accident pressed your mouse button and your mouse fell off the table and you released it, and maybe that happened within, I don't know, 0.2 seconds, something like that. You don't want that things like that are happening, so that players are by accident drag and dropping stuff around. So that's why you can say a specific drag time, and if the time of the drag and drop is below that, then it's simply ignored. I think the default value is 1/3 of a second or something like that. Here, so it's 250 milliseconds, so I was close, and this is the default value. We don't change it for now, but just that you heard of it, I think it's an important piece of information. There is this drag time information available that you can say, for example, I don't know, if you set it to 1000, then drag and drop needs to be at least 1 second, otherwise it won't be recognized by Scene2D. Okay, and then as mentioned, so our inventory slots are drag sources and drag targets. So for every slot that we have here, we are going to add a source. There we are going to create a new class, which we will call inventory drag source, and pass in the slot. And we're also going to add a target, which is an inventory drag target, where we also pass in our slot. And also a function that should be called when an item gets then dropped on that specific slot. So let's call that onItemDropped. And let's also create this function. So onItemDropped. What we get in here is the source slot. So from which slot did the drag and drop start? We get the target slot. So in what kind of slot was the item dropped, and we also get the item model, so what kind of item was drag and dropped, and this is the function that we pass in here. The drag source and drag target, those are again specific classes of drag and drop that I simply subclassed a little bit to bring in my own logic for the inventory system. That made sense to me, and hopefully it also makes sense to you in a moment. And the same thing we're going to need for our gear slots, because they are also drag sources and drag targets. Good, so let's create a new class again. So I added it to the widget package, and I called it inventory drag source target, because I add both classes to that file. So we are going to have an inventory drag source. As we saw before, that one takes the inventory slot, and it's going to extend the specific class, which is called source, from the drag and drop package from Scene2D. And a source needs to take in an actor, and this is simply our inventory slot. And then we have an inventory drag target. So that one again takes in an inventory slot. That one takes in a function which is called onDrop, which takes the source slot, which is an inventory slot. It takes the target slot, which is an inventory slot, and it takes the item model. And and it extends the target class of drag and drop, which also takes an actor. Okay, and then the source requires a specific method, and the target requires a specific method that we going to implement that. So the drag source has a so-called drag start function. So this one is called when a drag and drop is starting, meaning that this drag time was reached that we saw before in the drag and drop instance or class. And when the time is reached, then a dragging is starting. There we get in a specific event, we get the coordinates where that is happening, and I don't know what the pointer is. We also don't need it. Does it have to do maybe with the mouse, if it's the right or left mouse button? I think that would make sense. And with the drag target, there is the drag function. So that one is continuously called if there would be a potential drag into an inventory slot. So when our actor that we are going to drag is part of this target, so when it comes inside its hitbox, let's say. And there's also a drop function which gets called if an item gets successfully dropped, and this drag is returning a boolean which indicates if the drop is allowed or not. So if false is returned, then we cannot drop an item there or an actor there, generally speaking, in C2D. And if this function returns true, then we can actually drop something there. Okay, let's start with the drag start function. So first of all, if the inventory slot, if the item model is equal to null, then we are going to return null here. Oh, that one I did not mention. So there is a payload, a so-called drag and drop payload. So this is the payload, the information which is part of our drag and drop. So what kind of information are we dragging around, and what kind of information do we want to drop then there? So first of all, let's import it there, that we don't have this drag and drop everywhere in our source code. So there you also see that. So in a target, there's also this payload information. So what kind of stuff do I want to, am I currently dragging around? And yeah, for us, that will be mainly the item model information. That is the payload that we are going to pass in here. But here, so if we are in an empty inventory slot and the user tries to drag something out of it, then we don't want to have any payload, we don't want to have any drag and drop functionality. So that's why we return here, because yeah, you cannot drag and drop an empty item model. And otherwise, we are going to return a so-called payload, and here we are going to adjust it a little bit. Unfortunately, it's called object, which is a restricted name in Kotlin, so you need those ticks around that word. And the object is basically the payload information. And in our case, that would be from our inventory slot, the item model. Then we can set a so-called drag actor. So this is the graphic that we are going to show during the drag and drop. If we don't add that, then the user won't see what he is dragging around, which is not nice. So we are going to create a new drag actor, which is an image again from Scene2D. And this is again from the inventory slot. It's the item drawable. So that one we need to make it available, that we can use that here. Currently, I think it's private. And we also going to apply that image or change that image a little bit, because we are going to set the size of that image and make it a little bit bigger. So for example, let's say it's, I don't know, 22 pixels as an example, so that it's a little bit bigger. The normal item graphics are 16 by 16 pixels, if I remember correctly, and we want to have it a little bit bigger than that. Okay, and also one thing that we are going to do, so during the drag and drop, so when we drag an item out of our inventory slot, we want to clear the item actually from that specific slot, so that it's no longer in there, because otherwise it looks a little bit weird when we drag and drop an item from a slot to another slot. Then we have the item on our mouse cursor, and we also have the item in the slot, which would look very weird. So that's why we are going to clear it by setting here the null value. Okay, then let's quickly go to our InventorySlot. And there I was wrong, so we simply create here an extension property which we call ItemDroppable. That one returns a drawable. And in the get function, we simply take from our item image the drawable. So this is how I solved it. So now we can have here the item drawable, and now the set size function is properly working. And that's it for the drag source, I would say. No, actually we also need to override another function which is called drag stop. So there are different functions available, drag start and drag stop. I think that makes sense. And what we need to do, so since we have cleared the inventory slot here, and in case we have an invalid drag and drop and the item was not correctly dropped into another slot, we need to restore then the graphic that we have in here. So the payload is not null in our case. And what we do here, so if the target is null, which means there was no valid drop, then from our inventory slots, we again set the item, and that is simply from our payload, the object, and we can cast that to an item model because we know that we always set an item model as a payload in our case. Okay, so that should be it for the drag source. So when a drag is starting, we create this payload, which is our item model. We set a drag actor so that we see on our item our mouse cursor what kind of item we are dragging, and we are clearing the item from the inventory slot, just a graphic. We don't really do something with the model in the background. Just from a user interface point of view, we clear that. And yeah, if the drag and drop stops and there was no valid target, so the target is null, then we simply restore the graphic again that we cleared here, so that yeah, the item is from a user interface point of view correctly back in its original slot. Okay, then let's go to the target, which is now almost the last part of the drag and drop stuff. And there I forgot something, because we also need a supported item category information here. What is that? This is needed for our gear slots because, as I mentioned initially, so for example, in the helmet gear slot, you can only drop helmet items, or in the weapon gear slot, you can only drop in weapons. And we need to validate that. So that's why we need the information what kind of item is allowed to be dropped in that specific target. Okay, so let's start with the drag function. So there should always be a source and there should always be a payload. So let's remove the question marks here so that it's not a nullable type. Then we're going to get the item model, which is from our payload, the object, and we cast it as an item model. Then we have our drag source, which is our source, but we cast it to an inventory drag source, so that it's our specific type. We know that this is safe in the code area where we are working, so we don't need to check with an instance of, or with the is function in Kotlin. We can be sure that the payload object is always an item model and the source is always an inventory drag source. Okay, and we also want to have the source category, which is from our drag source, the supported category. So that one is currently missing, so let's add that to our drag source. So there we have an extension. It's not really an extension property, it's just a normal property actually, but without a backing field. We are just implementing a getter, and there it's from the inventory slot, the supported category, which we are also currently missing, but we're going to need that now soon. So let's implement that here in our inventory slot as well. So here we have a supported category, which returns an item category. Again, we override the getter, and we return when. That one we check on our slot item background. Maybe that's not the best way to do it, but this is how I solved it, and it's one way to make it work. So if it's the helmet drawable, then this slot allows helmets. If it is a weapon drawable, then this slot allows weapons, and so on and so forth. So same for armor and same for boots. And otherwise it returns the item category undefined. And that's it. Okay, so if it's the helmet background, we can drop helmets. If it's the weapon background, weapons, and so on and so forth. And coming back, so this can now be used in our drag and drop logic here. So that we get here now the item category of the source, so that we can now validate, is it allowed that we drop this item in that specific target slot. So here we are going to add now some validation. So first of all, if this is a gear slot and the item category is supported, then we can return true. So then this drop is allowed. Otherwise, if it is not a gear slot and the drag source, and we started the drag and drop from a gear slot and the inventory slot is empty, or the inventory slot item category is equal to the source category, then we can also return true. So this means that an inventory slot target and item gets dragged from the gear slot. And this is only allowed if an inventory slot is empty or contains an item of the supported category. Because otherwise we could, for example, when we have an equipped weapon and we are going to drag that back into our inventory and, for example, drop the weapon on the boots, then later on when we add this swap logic, we would then add the boots as a weapon. So that's why we need to check that if we are coming from a gear slot and we drop somewhere else, that the item which is in there is still allowed and valid. So let's quickly implement those things that we are currently missing. So first of all, we want to know, is it a gear slot? Here we simply check if the supported item category was defined. So if it's not null, then we know it is a gear slot. And then we have a function is supported, which takes in an item category and also returns a boolean, and that one simply checks if the supported category is equal to the category that gets passed in here. And in our source, we also need to have this information here if it is a gear slot. But here it's slightly different. So here we return from our inventory slot the information if it is a gear. So coming back to our inventory slot, how does it work? It's a function that returns a boolean again, and it's simply checking. And what is that doing? So it simply checks if the supported category is not equal to the undefined category. So then we know it is a gear slot. Okay. And let's also implement the other functions that we will be needing soon. So first of all, we have an isEmpty function or property. And a slot is empty when the item model is null. So when it does not have an item. And we also have an item category, which returns an item category. And there we have, if there is an item model, then we return the category, and otherwise we return the undefined category. So then there is no category defined for that slot. Good, so let me check. Okay, so looks like we have now all the functions available, but we are not finished with our validations yet. So here, if it is not a gear slot and the drag source is also not a gear, then we can do it. So this is simply a drag and drop between the inventory slots. So there we can freely swap around the items. That's not a problem. That is allowed. And otherwise, this is false. And here we set from the payload, the drag actor, we set the color to a red color, which indicates that you cannot drop the item in that specific slot. Okay, then we are going to implement a reset function. So this is happening when the drag actor is moving out of this drag target currently. And there we simply reset the color from our drag actor. Okay, and finally, when something gets dropped, so there we are going to call this onDrop function that we passed in as the constructor argument. So the source is the inventory drag source, and from that one, the inventory slot. Then the target is the current actor as an inventory slot, and the payload, from our payload, we take the object and cast it as an item model. And that should be it for the entire drag and drop stuff. So that was really a lot. Let me recap once more. So again, we have always a source and a target when it comes to drag and drop. Our inventory slots and also the gear slots are both. They are a source and a target. In the source, we can specify when drag starts, we need to return a so-called payload, which has this object, which in our case is the item model that we are going to drag and drop. We can optionally set the drag actor, which in our case is also the item, but just a little bit bigger than normally. And we are going to clear the image from the slot where we are starting the drag and drop. And when the drag is stopping and there was no valid target, then we simply reset the item graphic in that slot. And for the target inventory slot, so there in the drag function, which returns a Boolean, we need to, we can validate if a drop is allowed or not. So if we return true, the drop is allowed. And if we return false, then a drop is not allowed. And here, the first thing is that we check if it is a gear target slot. Then you can only drop the item there if this slot supports that specific item. So in a helmet gear, we can only drop helmets. In a weapon gear slot, we can only drop weapons. The second thing is more like a special case. So when we are dropping something which is not a gear, so in our normal inventory, but the source was actually a gear, so we are trying to unequip something, then this is only allowed if the inventory slot is empty or the inventory slot has the same item category than the source. So when we try to unequip a helmet, then we need to drop it into an empty inventory slot or into a slot which also contains a helmet, so that this is allowed. Otherwise, it's not allowed. Yeah, and finally, if the target is not a gear, so it's a normal inventory slot, and the drag source is not a gear, so it's simply a drag and drop between inventory slots. This is also allowed, and in all other cases, this is not allowed. This is false. We change the color of our payload drag actor to red. When we're going outside of this target, we reset the color to white, so then it's okay again for the user. And finally, when a valid drop is happening, so if we return here true and the user releases the mouse button, then we call the onDrop function that we passed in as a constructor argument to our drag and drop target. Okay. Okay, so let's import here now the drag source in our view and the drag target. And what we are missing here, so here for our gear slots, we pass in the supported category. So this third argument that we added here, so there is some extra special validation when it comes to that part here. Okay, so we are almost done now. So think if you got so far now and they understand everything, then good job, because I was the first time when I was learning this drag and drop stuff from Scene2D, I was heavily confused how it works, and it was not easy for me to implement it, but I hope that I explained it good enough that you could follow so far. The last piece that we are currently missing, so that drag and drop would not work now, although it's implemented, but it wouldn't work because our user interface stage is not an input processor of LibGDX. So maybe you remember that in our player input processor, I think that was the, let me quickly check, I think that was the only area where we set this input processor, exactly. So currently in our game, the only thing that reacts to some sort of input is our player keyboard input processor. So only the keyboard, for example, is working, or the mouse, but our stages, so the user interface stage or the normal game stage of Scene2D, they are currently no input processors, which means that when we click on the actors or do something, for example, type something in a text area, then this won't trigger or fire any events because it's not registered as an input processor. So we need to fix that, and one way, or the way I solve that, is that I simply added a new function in here. Let me explain that in a moment. So it's totally fine that you can have multiple input processors. So for example, the keyboard, then maybe the, I don't know, the controller, Xbox controller, and maybe also the different widgets from a Scene2D stage for user interface button clicks and so on. And in LibGDX, this is called an input multiplexer. So there are multiple input processors then processed at once. And normally, I would need to check, for example, here when I do a call like that, I would need to check, is there already an input processor available? If yes, I need to add it to the list of input processors, and otherwise I can set this processor here directly. And in order to avoid checking that everywhere where I want to set a specific input processor, I created my own function which I called GdX input processor, and that one is doing all that magic. So it takes in an input processor, and now what it's doing, so it gets the current processor, which is from our input, the input processor, and if the current processor is null, then it's fairly simple. Then we can simply set the input processor that we passed into that function. Otherwise, we already have an processor, and here we need to check now if it is an input multiplexer. So an input processor that already supports multiple different processors. Then if the processor is not in the current processors list of this multiplexer, then we simply add it. Otherwise we don't add it because it's already in there. And the third option, so if it is not an input multiplexer, then we need to create one because we need to support now multiple inputs at once. And there we create a so-called input multiplexer. We pass in the current processor, whatever that is, and we also add the new processor which was added there. And now in our list below here, we call now our function like that with this stuff. Okay, and that one we need then later on. Let's add that now that we don't forget about that, because then in our game screen, our UI stage, which contains then the drag and drop stuff, also needs to be an input processor. So in the show function here, we call here, maybe after the player input keyboard, we also pass in here the UI stage, as you can see, which is automatically an input processor. We pass that in here. So then both the player keyboard import and the user interface stage are both input processors. For our case, for the time being, in our inventory screen, something UI screen, there we don't have the player keyboard as an input processor, so we would not really need that. But I still call this function now, so that should still work. Okay, and with that, let's quickly test that, because now we should theoretically be able to drag something. So let's add these items, and now, yeah, perfectly. So I can already drag and drop something. So this input processing is now properly working. What will happen when we drop the item there? It disappears. And why is that? Because we did not implement yet the onDrop function in our view. But perfect, so the moving around or the dragging is already working. As you see here also this validation is working. So in the helmet slot, we can drop the helmet, but in the weapon, armor, or boot slot, we cannot drop it. So there we get this red color, which also gets reset when we are moving outside of this target. So everything with the dragging is already working. And what you can see here, so currently the helmet is a little bit, it's not centered on the mouse cursor, which I don't really like a lot. So that's why we are going to fix that. And there, if you remember, we did not call yet the drag and drop set drag actor position. So we are going to do that here. And this is just an offset that we need to set once. We don't need to set that all the time. And this is simply half of the size of our drag actor. To make that a little bit nicer, let's go back here and extract that one here, so the 22 pixels. Let's make that a constant. Let's call that, for example, drag actor size, which is 22 pixels. Then let's replace that in here. And now in our view, we can set that to the inventory drag source, drag actor size half, and minus inventory drag size. I cannot talk anymore. Half of that. So now that should also be fixed, that the icon or the item is now centered correctly in at our mouse cursor. And yeah, as you can see, it's now perfectly aligned. Good. Also, you see, for example, that is what I meant before. So when we drag something away from the slots, the item graphic disappears. And when we do an invalid drag, so for example, this is no target, this is just the background of the stage, then we reset the graphic correctly in the source slot. So that was the logic that we added there, so that you see that here as well. Good, so the only thing missing now is our drop function. So when an item gets dropped, and there I had a lot of funny bugs initially in it. So as I mentioned, for example, when you have a weapon equipped and you drop it back into the inventory, and there would be, for example, a boots item, then suddenly I would have the boots equipped as a weapon and things like that. So there are actually quite a lot of scenarios that can happen in just a simple inventory as we have it here. Yeah, but I hope I took care of all of them and that it's working then properly. So item dropped, what is happening here? So if the source slot is equal to the target slot, then nothing happens because the item was dropped on the same slot. We don't need to do anything, nothing happens. Otherwise, we want to swap our items between the different slots. So from our source slot, the item is from our target slot, the item model, and target slot item is the one that we are currently dropping. So that gets dropped in this onItemDropped function. So this is graphically the user interface updated from a swap items. And below here, that comes later on, update model as well. So that one we are going to implement later on, that also in our player entity, that the inventory gets correctly updated. Okay, what we are currently missing is just one more function here, which I called gear, and that one is similar to the item function here, that it places an item in a gear slot. And here from our gear slots, we get first or null, the slot where the supported category is equal to the item model category that we passed in here. And if there is one, then we set the item to the item model. So then we correctly add this item model to a specific gear slot. So this is how I implemented that one there. We don't call that yet, but this will then be part of the update model, just that we have it here. And we could now theoretically also call that in our inventory test screen, but I think, just believe me, that this is working properly. And with that, I would say we have the biggest part of this video. So we have now this drag and drop functionality completed. Let me quickly go through it one more time because I think it's really quite a lot. So the important things are happening in this setup drag and drop. There we create a new drag and drop instance from scene to D. We make sure that the item that we are going to drag, that where we have the size of the actor, that it's correctly centered in our mouse cursor. Then we make every inventory slot and also every gear slot. We make it a drag source and also a drag target. And all the logic of the drag source and the drag target, we covered that before. And with that specific setup, and also by, this is very important, but also by setting the stage as an input processor, we can then correctly drag and drop things around in our inventory view, which is great. Okay, so the last part now of this video is that we are going to add now all the model logic that we need, so that our real player is then carrying the items, that we are creating the item entities and everything. But from a user interface point of view, we are, I would say, finished so far. Of course, there is still the data binding currently missing and the update model stuff here, but that is coming now. So let's go to our inventory model. So here we need to add now a couple of logic that we are going to need. So first of all, we are going to extend our property change source that we have also, I guess, added in the last part, if I remember correctly. And yeah, this is actually then to also notify the view if there would be item changes for our player. Then we need the player components, which we simply get from our world. We also need the inventory components. And we need the item components. And finally, we want to have all our player entities. And we want to have the player items, and this is now by the property notification, and by default it's an empty list of item models. So this is what we are going to use for the data binding between the model and the view. So let's quickly add that to our inventory view, where we have the data binding. So here from the model, on property change, the property that we are going to listen are the player items, and there we get in the item models. And then first of all, we are going to simply clear everything that is in the current inventory and gear, and then we rebuild everything. So for every item model that we then get passed, if the item is equipped, then we call the gear function, and otherwise we call the item function. So what we don't have yet implemented is the clear inventory and gear, and there it's simply that we go over all our inventory slots and we set the item to null, and the same for our gear slots. So that way we get rid of all the items which are in there, and then we can rebuild everything like here. So that one is then already working. So whenever we get now new player items, then our user interface will get updated accordingly. Good. And as always, we need to add our model as a listener, so that it reacts then to the different events that we are going to fire soon. So like, for example, I don't know, player item pick up or player item drop events, things like that, that the model can react to that and update then everything. Okay, which brings us to our handle event function, and there we are going to create a new event for now. I think that should be sufficient. So if it is an entity at item event, then we do something. So we don't have this event yet. So let's create that. So there we have a entity item event, for example, the entity which gets the item, and then also the item for itself, which is also an entity, and there we take in the event. So what we want to do here, so if the entity from the event is a player, then we want to do something. Then our player items is equal to the items that we have in our inventory component. And that one we don't have yet implemented. So now we need to update our inventory component. So here, when this event gets fired, we also write a separate system for that. And yeah, when an item gets added and it is a player, then we update the player items accordingly. So let's go to our inventory component. Here, in the past, normally I always implemented the inventory like an array or a two-dimensional array, and in there I added in the specific x and y coordinate an item. But this time I used a different approach, which I think is easier to implement, and you don't have the problem that you maybe run into an index out of bounds exception or something like that with the different arrays. So here I simply get now or store a list of items, which is again some entities in our case. And I also allow from the outside that you can add items, which is a so-called item type, which we are also going to add in a moment. And the item itself, so the item entities, they simply have the information in which slot index they are. So for example, I could have an item in slot index 3 and an item in slot index 10, and that would be it. So in this list, I just have two items, and the item itself has the slot information. And with that, I don't need this two-dimensional array or things like that, which makes it, in my opinion, a little bit easier to implement. And also, we need to define our inventory capacity. And our user interface currently supports up to 18 item slots. So let's also say here that we can store 18 items. Okay, next thing, we are going to create this item type. So this is done in our item component. So what is an item type? An item type has, first of all, a specific category, and it has an UI atlas key, so the graphic of the item itself. And there we have, for example, again, undefined, which has the item category undefined, and it has no graphic. Then we have, for example, a helmet, which has the item category helmet, and the atlas key is also a helmet. Then we have a sword, which is a weapon and has the index sword. And sword, or for example, big sword, that one has the key sword 2. And yeah, that's it. Let's add the boots, and I think that's it. We also have an armor, but I think you get the idea how this item type is working. So it's basically defining a specific item type. An item always belongs to a specific category, and an item should have a specific graphic. Okay, and the item itself. So as I have mentioned, an item has an item type, which per default is the undefined item type. Then it has a slot index, which per default is -1, and it has the information if it is equipped or not, which also by default it's not equipped, so it's false. Okay, so coming back to our inventory model, we can now get from our inventory component, we can get the different items, and we want to map them to an item model. So we return an item model, and there we return the ID of the entity. Then, let's also say here we want to get the item component of that specific item entity. So from the item component, we want to get the item type and the category. Then we also need the atlas key information, the graphic. Then we need the slot index, where is it located, and we need the information if the item is equipped or not. So basically all the entities from our model, we convert them to a user interface item model, and we have the linkage to the original entity via the ID information of the item model. So this is how it's done. And here, if it's any other event, we return false. So then we did not handle it properly. Okay, then we need to add now items to our player. So let's go to our entity spawn system, and somewhere in here we create the player. Yeah, it's here. So if the type is a player, we add the player component and a state component. And now we're also going to add that inventory component. And there we are going to add some items that the player should get. So for example, he gets initially a sword, then he gets a big sword, and he gets a helmet, and he gets some boots as an example. So this is the initial equipment of our player. And now we need a system, because these items, they are just part of the component, but nothing is happening with them. And also we don't fire the event yet for our item model. So we are going to create a new system that we are going to call InventorySystem. An InventorySystem iterates over all entities which have an inventory component. And we need the component mapper for the inventory components, and we need a component mapper for the item components. And finally, we need our game stage, where we are going to fire then the event. And this is an iterating system. And that's it. Okay, so what is happening with an entity which has an inventory component? So first of all, let's get the inventory. And if there are no items to add, then we don't need to do anything, because we don't need to add any items, which is great. Otherwise, if there are items to add, then for every item, we need to get an empty slot index. So the next slot which does not have any item, where we could add this new item. So that one becomes a new function. And there we simply iterate over all inventory slots that we have. We check if there is no item in our inventory currently available. For that specific slot index. So if there is no item in that specific slot, then we know that slot index is free, and otherwise, if there is none, we return -1, which means we don't have any slot which is currently free. So we also check that here. So if the slot index is -1, then unfortunately we cannot add the item, then we simply return it. And otherwise we create a new item. So let's call that spawn item, where we pass in the item type and the slot index, and we're going to add this item to our inventory. And we're also going to fire then our event. So there we fire now our entity at item event, and we pass in the entity and the new item. And finally we want to clear all the items that we iterated here over. And yeah, that's it so far. So let's finally create this spawn item function. And there we simply return a new entity, so which is our item entity. And that one just has an item component where the item type is equal to the item type that we pass, and the slot index is equal to the slot index that we pass. Okay, and we need to, of course, add this system to our game. Let's do that after the loot system, for example. Okay, so theoretically, we should now, when our player gets created, we should add items to him. Our inventory system should create the new items and trigger then our item model, that it gets notified that there are some changes. And the only thing that we are currently missing is that we cannot open the inventory view at the moment because we did not add it yet. So let's also do that. So after we are adding our game view, we are also adding our inventory view, which takes an inventory model with our worlds and the game stage. And in our player input processor, there we need to add something new. So here, when the key code is equal to the I key for inventory, then we are going to toggle our inventory view. So we take the user interface stage, which we did not add yet. So let's add that as well. Okay, so from our user interface stage, we get all the actors and we get the second one because we added the inventory as the second actor here. This is again not ideal. I would not program it like that. You should maybe iterate over all actors and get the one with the correct type. But for now, let's keep it simple. We know it's the second one. And there we simply toggle the is visible information, which is just the opposite of the current information. So that's how we toggle this inventory view. So back in our game screen where we create the player input processor, we also need to provide the user interface stage. Oh, and let's move that up as the second argument of the input processor. Okay. So let me think now. So now we should have everything. Let's let's just try it out. Oh, of course we need to change our screen. So now we want to go back to our game screen. Okay, things are looking good. We have here the 4 items. The inventory is immediately opened. That one I maybe don't like. We need to change that in a moment. But we have the 4 items, so the system is obviously working. Also the drag and drop in the real game is correctly working. We can drop something here. We can drop the helmet here. We cannot drop the boots there. So there everything looks good so far, I would say. So here also you see that we cannot drop a weapon back to a boot slot. That won't work, but we can drop a weapon back to another weapon or to an empty slot. So there everything looks good. We are almost done, almost. Okay, so let's adjust the inventory view. So here we want to initially set the visibility to false. So we don't want to see the inventory view immediately. Good, and the only thing that is now missing is the last piece of information, that we really also update the model in the background correctly. So from a user interface point of view, everything looks like it's working, but actually in the background with the player entity, nothing is happening yet. So we also want to fix that now. So for that, we go to our inventory view. Let's close everything else, and now finally we come to our item drop function here. So here we are now going to update our model. And what are we doing? So first of all, we get the source item, which is from our source slot. the item model. And be aware, so this can be null if the target slot was an empty inventory slot. Then we are going to check, so if the source slot was a gear slot, so then we unequip something from our model. So what we do here, first of all, we're going to equip in our model the new item model and say false. So we want to unequip it. So we remove the current item which is there. And then if the source item exists, so if it's not null, then we also going to equip it. Okay. And otherwise, if the source item exists, then we simply say, we call the inventory item function, and we want to update the slot of the source with the source item. So this is the update functionality for the source, and very similar, we need to do the same stuff for the target slot. So let's just copy and paste that here. So if the target slot is a gear, then if the source item is not null, then we unequip it, and otherwise we equip it. And otherwise we don't need to check that anymore. So from our inventory slots, again for the index of the target slot, there we are going to equip the item model, so the model that gets currently dropped. So this is everything that we need. So we currently are missing an equip function so that we can equip and unequip an item, and also an inventory item function that we can update a specific inventory slot. And I think I'm missing a bracket here, no? Okay, now it's correct. Good, then let's create those two last functions. So we need an equip function. And we need an inventory item function. So equipping is quite easy. So we get the player item by model. So this is then matching via the entity ID that we have stored in the model. And there we set the equipped information to the equip information that we pass to the function. And we also update the user interface model accordingly, that it also indicates if it's equipped or not. What is this player item by model function? It returns an item component, and it simply returns from the item components from our player inventory components. There we get the items, and there we get the first one where the ID is matching the item model item entity ID. Okay. So player inventory component, what is that? So that there we have the property again, which returns an inventory component, and there we override the getter, which is from our inventory components, from the player entities, and we know we just have one player, so we simply pick the first player entity that we find there and return that specific component. Okay, that's the equip function, and then the last one, the inventory item, and then we are done. So there again we get the player item by model, and we update the slot index to the slot index that gets passed in here. Again, we update also the user interface model slot index, and that's it. So what I did here to also debug if everything is really working in the background, I called here a function which I called debug inventory. Let's also implement that quickly together, that you also see then that everything is working properly. So what we do in here, we need to, first of all, we need a logger for that class so that we can log something. A logger for our inventory model. And now, so let's debug something. So here we say inventory. Then we go over all the items in our inventory. And there we print out from the item the item component. And finally another empty line. And if we did not do, okay, we don't need to remember the game stage, I just see that. And the words, I think we also don't need to remember it. Okay. So if we did not do any mistake, we are done now. Let's see. I would be surprised if everything is working with the first go. So first of all, the inventory is no longer opened immediately, so let's open it up. And now let's move the boots from slots 1, 2, 3 to 5. Okay, so we get this information inventory. We have a sword in index slot 0, the big sword in 1, the helmet in 2, and the boots in 5, and they are not equipped. Now let's equip the boots. So now everything is the same, but now for the boots, the equipped information here has changed to true. When we go back, it updated now that it's no longer equipped and it's in slot index 17. We can swap stuff around, we can equip stuff around. Everything is working on the first try. I'm surprised. Perfect. So I know this was a super long part. But I think it's also actually a lot of functionality that was added there and a lot of information, especially with the drag and drop. I think that should be everything that you need to know about the drag and drop function. What we did not do is, as mentioned, implement everything that could be added to an item, like for example that it gives stats like damage or life or whatever. What I normally do there, I add then a stats component, and an item then simply has a stats component. The player also has a stats component, and those things get added up in the inventory system. We did not implement an item removal or item selling to a vendor or things like that, but I think with what you have learned in that video, you should be able to implement everything that you could imagine when it comes to those topics. And yeah, with that, I thank you again for watching. I hope you enjoyed it. Sorry again, was a longer part, but yeah, that's it. Enjoy the rest of your day, have fun, and bye bye.